Hey guys, it's Yahya from the Perspective Show, and today we will be talking about how a Greek scholar named Euclid figured out the wonders of the universe using some common notions and definitions, and why it's so foundational to the very present we live in today. Right on, guys. Oh, hey, let's pick up where we left off. Now, no one really knows that much about Euclid, his life or what he looked like, but let's pretend this image is him 2,300 years ago. The best knowledge we do have of Euclid is that he was a scholar who moved from Greece to go work in the Library of Alexandria early in its founding. He was a mathematician and is most famous for his work in geometry. You might have heard of him first in your 9th grade geometry class with such prestigious titles as Euclidean geometry or even Euclid, father of geometry. But first, let's get some facts straight. Number one, Euclid was not the first to invent or even study geometry. Geometry, coming from the Greek word suffix geo, or earth, and mitra, or measure, could be taken all the way back to our ancestors, first looking at angles, or the Egyptians first understanding shapes and areas, or even Pythagoras' work on the nature of shapes and solids. The reason Euclid has gotten so many prestigious titles and is remembered today is because of his greatest work, the elements. You guys still around? Okay. What is the Elements? Euclid wrote the Elements, a large 13-volume mathematical textbook to try a rigorous and logical deductive search through geometry, three-dimensional geometry, the basics of algebra, and even number theory. From the very beginning of Euclid's search through these subjects, he wanted to have a concrete understanding. He wanted to only deal with ideas that were 100% factual and not just probable, like you see in most of science today. Do you guys know how he did that? Axiomatic deductive reasoning, of course. Let's go back to the basic. Hey guys, we're back to the basics. So, let's explain axiomatic deduction through its best source, the Elements, and one of my favorite sources as a kid, Jenga. In the beginning of Elements, books 1 through 6, Euclid starts out with basic assumptions and definitions. Now, let's say these 5 blocks are the definitions. For example, block 1 says, given 2 points, there is one straight line that joins them. Block 2 says, a straight line segment can be prolonged indefinitely. Block 3, a circle can be constructed when a point for its center and a distance for its radius are given. Block 4, all right angles are equal. Block 5, if a straight line following on 2 straight lines makes the interior angles on the same side less than 2 right angles. Now, let's go to these other 5 blocks, right? I've written down, things equal to the same thing are equal. 7, if equals are added to equals, the wholes are equal. 8, if equals are subtracted from equals, the remainders are equal. 9, things that coincide with one another are equal. 10, the whole is greater than a part. What can you say about all 10 of these blocks? They are so basic in their truth that it would be impossible to deny them as false. Can you really deny that things equal to the same thing are equal? Of course not. It's so basic that everybody knows it's true, and you look pretty silly if you deny it. These 10 blocks are called axioms. Axioms are the basics. They are the things so common or fundamental, no one can deny them. From here, Euclid built. Now we'll call these 10 blocks or axioms our foundation. Let's put another block on top of axiom 1. Given 2 points, there's one straight line that joins them. And axiom 2, here, let me put it in a better view. Axiom 1, given 2 points, there's one straight line that joins them. And axiom 2, a straight line segment can be prolonged indefinitely. So, let's use, Jenga. So, let me hurry and build this as our foundation. Okay, and then I'll put our whole thing. Notice that the whole Jenga set is being built off the foundation. Euclid continues to build more theorems of mathematics, each supported by lower theorem blocks, which are supported by lower theorem blocks, which are supported by lower theorem blocks, which are then lastly supported by the fundamental truths or axioms, or foundation of the whole block structure. Do you see why the Elements is so important? Euclid was the first person to axiomatically prove and build a whole field of knowledge. Euclid started at the bottom with these 10 fundamental blocks or axioms, and built a whole field of knowledge that was all true because it was supported by these fundamental truths. You could start from the very beginning definitions and follow all the way up to the most complicated theorems, or start at the highest level and trace it down to the basics, with everything you get fully learned. Now, let's say for some reason that one of the fundamental truths are wrong. Euclid made sure they were wrong because they were so basic, but let's say you were doing something and they were wrong. Let's see what would happen. The whole field of knowledge would collapse. See, if one of the fundamental truths are false, then the whole field of knowledge that were built from them are false as well. With the M elements, Euclid would set a standard for deductive reasoning and geometric instruction that would continue untouched for another 2,000 years. Hey guys, let's talk about the legacy of Euclid and the elements. As you can believe, the elements instantly became all the rage throughout the world. It first traveled throughout the Mediterranean in its original Greek and started to influence other Hellenistic scholars, most notably a man named Apollonius, who later applied the same axiomatic methods picked up from Euclid to cones. He later defined multiple cones and went on in more detail, discovering conic sections and concepts like ellipse, parabola, and hyperbola. Years and years later, the book was translated into Arabic by Arab scholars, most notably a man named Al-Hajjaj ibn Yusuf ibn Matar, who preserved it and thought it to be a masterpiece. It was then translated to Latin and spread throughout Europe like wildfire. He became a rock star to the intellectual elite. You could not think of yourself as an educated man in Europe without reading the elements. After first publishing the Bible, can you guess what Johannes Gutenberg used as his second book? You got it. The Elements. It is thought that the only other book to sell, be translated, studied, or influence more people in its copies was the Bible. Let's not forget, this was a math textbook. Think about that. What's so amazing about the Elements is that Euclid's system, which we now call the axiomatic deductive method, would define the next 2,000 years of scientific thought and development. This idea of a handful of true principles to acquire an infallible understanding of any field, thought process, or subject matter permeated through all philosophical, scientific, and mathematical fields. Baruch Spinoza was so influenced by Euclid that he wanted to do the same axiomatic deduction in philosophy to find one true way of living and understanding. One truly wanting to be the Euclid of philosophy. René Descartes later invented Cartesian doubt and other methods of skepticism to get rid of untrue methods and build axiomatically true ideas for philosophical notions that could answer deep questions in metaphysics and actual physics. You can see this best with his famed tree model. You can really tell he wanted to be the Euclid of metaphysics. Isaac Newton's Principia, which we think to be a foundation of modern physics, was based on Euclidean ideals. It started with the basic definitions and axioms and went on to build large and complicated physics theorems. Out of them, he wanted to be the Euclid of physics. Euclid had gotten all his predecessors from Pythagoras' mathematical conceptions to Plato's solids, even Aristotle's notions of analytical thinking, and built a book so based on truth that it became not only foundational to most of modern science, but a perfect model for what the human mind and scientific thought was capable of. Every time we open up a computer, ride in our car, use our phone, look up to see a beautiful building, or yes, open up our 9th grade geometry book, we can always thank the ancient Greek genius we know today as Euclid of Alexandria for deducing the laws of nature, or as he liked to call it, the thoughts of God. Thank you guys for joining me in Perspective Show, and I hope you learned a lot about Euclid of Alexandria. See ya!